Hello everyone, my name is Hw8, and today I will introduce the method that I use to solve the question 9 on homework 8. The question 9 asks us to find the probability masses functions of p of x big xi equals to small xi, big xj to equals to small xj for any I and j equals to 1, 2, 3, and for all positive integers. So we are given at x1 and big x1, x2 to the infinite xa is a Markov chain. Then it's statistically determined by the second order probability mass functions of this. So now let's prove this. First, let's focus on the Markov chain. For each state in this chain can be denoted as this. The output is only determined by its input, so the Markov chain has only a short memory, which is determined by the past, but the second order of is past. So first, let's say the probability of big X equals to small s, big X2 equals to small x2, and so on with big Xn equal to small xn. We can also draw the state of the Markov chain in a axis. So now let's take some tricks to this probability, and we use a conditional probability to depart this probability. First, we wrote that the conditional probability of big xn equals to xn when under these conditions times the probability of the big X minus n equals to small x minus n, and so on. So we do this recursively until we get these functions, which we can depart all the elements by the conditional probability, and with the last part is the probability of big x1 equals to small x1. And we can rewrite these functions into a sammutation. So the probability of big xi equal to small xi equals to the sammutation from k to the minus infinity to positive infinite. Sammutation of probability of big xi equal to small xi and big xj equals to small xj. The I and j is integer. And also we can write the conditional probability of xi and xj. Xi and xi minus 1, which is a state before xi. And we can also confirm the Markov chain has only short memory because the output only related to its input. We don't care about the past. We only care about the last element before the last element before the output before xi. So we can write the conditional probability of big xi equals to small xi like this. And furthermore, let's say this equations. This equations is a conditional probability but has n minus one condition. But the conditions only, but there is only one conditions affect the probability, which is the xn minus 1 equals to small xn minus 1. The other conditions doesn't matter with this probability, because Markov chain only has a short memory, so we can write this probability into the under the condition of xn minus 1 equals to small xn minus 1, the probability of xn equals to x small xn. So we can cut the past state. We only care about the states before xn. So, and finally, the result of the probability mass functions can be denoted as these two functions. That's all. Thank you.